In this video, we will try to start a new chapter, that is choices under uncertainty. Okay, before we talk about uncertainty, let us talk about the certainty. Okay, let's take an example. Let us say we have a consumer. Okay, he is buying a consumption bundle XY. Okay, so he pays for this consumption bundle, and this consumption bundle is giving him a certain level of utility. Okay, so this situation, we will call this certain outcome. Okay, certain outcome. Okay, so there is no uncertainty involved in this outcome. Consumer is going to purchase this bundle. Okay, this means it's a certain outcome. He is getting a certain level of utility uh, from this deal. We say this choice is a certain choice. Okay, let's talk about another example. Let's say we have a firm. He is producing good eggs. Okay, and he is selling this. He tries to sell it at, let us say, $2. Okay, in this case also we have certain outcome. Okay, certain outcome. Okay, so these are the certain events. There is no uncertainty involved. Okay, let's talk about the situations where we have uncertainty. Okay, to give an example, let's have a consumer. He is buying a used car. Okay, used car. Okay, if he is buying a used car, if he is lucky, the car will be in good condition. Okay, good condition. If he is unlucky, the car will come out to be a lemon, what we call the damaged car. Okay, damaged car. Okay, this is an uncertain situation. When the consumer is purchasing this used car, this car can be a good one or it can be a bad one. Okay, let's talk about another situation. Let us say a consumer is buying a lottery. Okay, lottery. Okay, when he buys this lottery, there are two outcomes. Let us say either he wins or he loses. Okay, so in this case also we have uncertain outcome. Okay, and let's talk about let's give another example. Let us say we have a consumer. He is buying shares. Okay, shares of any firm, and in this case the value of the share can go up or down. Okay, in these three examples we have the consumer is making choices under uncertainty. Okay, what we call choice under uncertainty. Okay, so I hope you understand what I mean to say. So these two outcomes are the certain outcomes, and these three outcomes are uncertain outcomes. Okay, now whether the outcome are certain or whether the outcomes are uncertain, the consumer always tries to maximize his preferences, whether be in the certain outcomes or uncertain outcomes. In this video or in the upcoming lecture series, we will try to understand how the consumer is going to optimize his let us say what we call the preferences uh, under uncertain situations. Okay, now let's talk about a representation of uncertainty probability distribution. Okay, so in a presence of uncertainty, when we have uncertain outcomes, we have what we call the probability of occurrence of an event. What is meant by this? First, we will try to learn about what is meant by expected value. Okay, then I will give you an example of this expected value under uncertain event. Okay, so let's write expected value. What is meant by expected value? Expected value is actually a mean or the weighted average of a random variable. Okay, so let me write it here. Is a mean mean or weighted average of a random variable. Let's say we have x, okay, and it is being given by this. Expected value is being denoted by this summation of xi pi, okay, and this pi, that is probability, it lies between 0 and 1, and summation of the probability is equal to 1, okay, and this is xi, okay. So what is this xi is our random variable, okay, and this pi is the probability associated with this random variable. When we multiply xi into pi, we get the expected value. That means random variable, when we multiply a random variable with the probability associated with that very random variable, we call it the expected value, okay. Now let's talk about an example to make sense of this very thing what we mean, what we have talked here. So let's take an example of an individual, okay. An individual's probability of an individual salary hike, okay. Let us say we have an individual and we want to see his salary hike, okay. Salary hike, what is the probability associated with this? I am talking, this is an uncertain event, okay. So let us say there is 0.1, that means 10% chance that his salary will not be increased, okay. 10%, 0.1 obviously means 10%. 10% chances are that his salary will increase by $1,000, okay. uh, let us say again 10% chances are that his salary will increase by $3,000, okay, and 40% chances are his salary will increase by $5,000, okay. I'm just giving an hypothetical situation of an individual about his salary hike, okay. And let us say 0 point, what we call 20% chances are his salary will increase to $7,000, and 0.1, what we call 10% chances are his salary will increase by $9,000, okay. So these are the random variables, and these are the probabilities associated with these random variables, okay. So that means 10% is chance that his salary will not increase, 10% chances is his salary will increase by $1,000. Similarly, they are accordingly being given here, okay. Now what we want to see, we want to see the expected salary hike, okay. Expected salary hike, okay. Now using this very formula, that is expected value, what we can write, we need to multiply each outcome with its probability, okay. So we multiply each outcome with the probability associated with that very outcome. That means expected salary hike, let us write it like this: expected value will be equal to, we have 0 into 0.1, okay, then we have 1000 into 0.1, plus then we have 3000 into 0.1, plus we have 5000 into 0.4, plus 7000 into 0.2, plus we have 9000 into 0.1, okay. 0.1, just using this. Expected value is the mean or weighted average of random variable x, okay, and this is given by this very example, okay. When we sum up uh, when we sum up the random variable and multiply it with their probabilities, okay, we get the expected value here, okay. We can say in this case expected salary hike When we solve this out, this will come out to be a number. Let us say it is 4700. Okay, that means the expected, we will expect that the individual's salary will increase by 4700. Okay, so this is the expectation. This is an uncertain event here. Okay, so this is the meaning of this expected value, and we have seen that we will also call this the expected monetary benefit here. Okay, expected monetary benefit that this consumer will get according to this uncertain situation. Okay, now let's give an example whether the consumer is always trying to maximize his expected value, or he is trying to maximize his expected utility. Okay, so let's take another example. Consider an agent who is making a choice between two investment offers. Okay, so the consumer is being given two investment offers. Okay, let us say this is plan A. Okay, in this plan A, payoff is coming out to be and this is the probability associated with this payoff. Let us say he gets $10 with probability of 10%. Okay, with probability 0.1, what we call 10% chances are he will get $10. Okay, he gets $20 with probability 0.3. He gets $30 with 0.2 probability. He gets $40 with probability 0.2. He gets $50 with probability 0.2 again. Okay, this is plan A. This agent has to make choice between this plan and another plan. Let me write it here. Let us say we have plan B is being given by this. We have the payoff and probability associated with this payoff. Okay, let's say he gets $10 with probability 0, $20 with probability 0.3, $30 with probability 0.4, $50 with probability, let's write it here, 40. Okay, $40 with probability 0.3 and $50 with probability 0. Okay, so what we mean to say that there are 0% chances that he will get $10, 30% chances he will get $20, 40% chances he will get $30. Okay, so these are the two choices for an agent. Okay, to choose between them. Okay, now what is the expected value of this very what we call the expected monetary benefit? I will call it expected value here. Okay, what is expected value in this case? Expected value in this case will be, we multiply each random variable with the probability associated using this formula. So this is 10 into 0.1 plus 20 into 0.3, then we have 30 into 0. Plus 30 into 0.2 plus 40 into 0.2 plus 50 into 0.2. When we solve this, it is very simple. You will get a number that is 31. Okay, so we can say expected monetary benefit from this from this situation is 31. Okay, now what is the expected value of this very function? This very situation, expected value in this case will be equal to multiplying each random variable with the probability associated with this. So we have 10 into 0 plus 20 into 0.3 plus 30 into 0.4 plus 40 into 0.3 plus 50 into 0. Okay, I'm not going to make these calculations. I have calculated this because it will get then lengthy, and it's not, you know how to multiply these numbers. Okay, so in this case the answer will come out to be 30. Okay, now we have a consumer. He has options. He will choose either A plan or B plan. Okay, in this case expected value from plan A is coming out to be 31 and expected value from plan B is coming out to be 30. Okay, we might expect that agent to choose investment that provides highest monetary benefit, in this case 31. Okay, so this approach makes sense that he will choose 31. Okay, and obviously it is natural to believe that agent maximize their expected monetary benefit in this case. Okay, which in turn maximizes their expected utility. Okay, so if we say that expected monetary benefit is 31 and it also maximizes it is what you call the expected utility, whether this will be the always case, uh, rather I will say like this, whether it is always that when we get expected value, okay, maximum expected value, and this will give us the maximum utility. Okay, but unfortunately this is not the case. Okay, why? So let's take another example where we will see this expected, it is not always that expected monetary benefit will give an agent maximum utility. Let's take an example to see whether the maximum expected value, that is, whether maximum expected value always leads to maximum expected utility or not. Okay, so I will explain this with an example. Let us say we have a patient. Okay, a patient a patient gets a sad news. This patient gets a sad news from the doctor, and doctor tells him he has exactly 2 days. Okay, he has 2 days to live, 2 days to live, unless he goes for a surgery. Okay, and this surgery costs him exactly $20,000. Okay, he, if he is able to produce $20,000, he will go undergo surgery and then he will be able to live, otherwise he will get exhausted in 2 days. Okay, this is a situation. In 2 days, let us say he calls all the friends, the near and dear ones, for help, but he is not able to raise a single penny. Okay, so they don't give him a single penny. Badkismat bichor. Now, with 1 hour left to live, he comes in contact with a dealer. Okay, so a dealer, he comes in contact with a dealer. Okay, and this dealer offers him to choose between two gamblers. Okay, he does not give him 20,000 outright. um, he asks him to choose between two gamblers. Let us say this is gamble A and gamble B. Okay, in gamble A, he receives, let us say he receives 10,000 bucks, $10,000 with 50% chance, that means 0.5. Let me write it here like this. 50% chances are that he receives $10,000, and 50% chances are he receives, let us say, $15,000 with probability 0.5. I am using this notation. It is not any standard notation. I am just trying to make it clear for you people. Okay, so this is gamble A. This is the situation A. He either receives $10,000 or $15,000 with same probability. And the next gamble that he is being offered to choose is that he receives $0 with probability that is 0.99. 99% chances are that he receives nothing, and 0.01, that means 1% chances that he receives or he wins exactly $20,000. Okay, now in this in the both situations we will see whether the expected monetary benefit, what we call the expected value, will maximize his utility or not. Okay, so let's take the gamble A. Let me write it here. We have gamble A, so let me write this like this: GA, that means gamble A. In gamble A, what is the money he receives? Let us write it like this. Let us denote this as price. Okay, this is probability. Okay, what is the price he receives? $10,000. Okay, with probability 0.5, 50% chance are that he receives $10,000, and also 50% chance are that he receives $15,000. Okay, this very thing which I have explained here. In gamble B, let me write it here. So we have gamble, or let me write it here again. Um, and we have gamble B. Let me write it like this. In the gamble B, what we have, he receives $0 with 99% chance, and he receives $20,000. There is a 1% chance that he receives $20,000. Okay. Now if we calculate the expected monetary benefit, what we call the expected value, let us see what is the expected value in the both cases. So expected value for gamble A, expected value for gamble A will be simply multiplying the random variables with their probabilities, which I have explained to you. So this is $10,000 into 0.5 is 1 upon 2 plus $15,000 into 1 upon 2, and this gives him the extra expected monetary benefit. When you solve this, will come out to be 12,1500. As I told you, expected value is the mean or weighted average of random variables with their associated probabilities. So for gamble A, he receives $12,500. Okay, now for gamble B, what is the expected value of gamble B? Let me write it like this. Expected value for gamble B is simply multiplying, so he receives $0 with probability 0.99, that means 99% chance are that he receives nothing, and he receives $20,000 with probability, that is 1% chances that he receives $20,000. Okay, and when we solve this, will come out to be 200. Okay, so in gamble B, he receives 200. Okay, in gamble A, he receives $12,500. Now what can we say about this patient? The patient needs exactly $20,000. Which of the two gambles he will choose? Okay, so if we compare the expected values, we will expect that he will choose 12,500. Okay, but let us see what is the utility of money. What is the utility of dollar here? So let me write here, utility of dollar here. Okay, now utility of dollar is simply, let's denote the two numbers. Let us say 0 denotes he dies. Okay, death. 1 denotes that he lives. Okay, now what is the utility of dollar in this case? So if he receives $10,000, okay, with 50% chance, utility of dollar is for him nothing, so it will be 0. Okay, he will die in this case. Similarly, if he receives 15,000, he will also die here. Okay, so if he receives nothing in gamble B, he will receive 0. Okay, utility of dollar will be 0. What is utility here? Utility is here that he should live. Okay, what is the utility in this case? In this case, utility is 1. Okay, in the last one. Okay, now if we try to, since we are not being given a utility function, I have defined these very things here. That means if we call utility of death as 0 and utility of life as 1, then if we draw this, and we will be able to find the expected utility then. Oh, okay, now let us see what is the expected utility in gamble A. Expected utility in gamble A means we multiply these random variables with their probability. So we have 0.5 into 0 plus 0.5 into 0, 5 into 0, that comes out to be expected utility for gamble A is 0. That means he will die eventually, whether he receives 10,000 or 15,000. Okay, but in gamble B, let us see what is the expected utility. Expected utility in gamble B will be multiplying this. We have 0 into 0.99 plus 1 into 0.01. Expected utility in the gamble B is equal to what we call, if we multiply 0.01. Okay, if the here we can, you can think like this: if our patient is maximizer of expected monetary value, so then he will choose gamble A, because expected returns are 12,500. But there is the trick here. In this case, patient will die in an hour. Okay, but if he chooses gamble B, though the expected monetary value of gamble B is only 200, okay, he has at least 1% chance, okay, 1% chance to live. Okay, hence the money to be received in gamble A is worthless because he will die eventually. Okay, but in this case there is at least 1% chance that he will live. Okay, so the point that I want to make here is that when making decisions in situations involving uncertainty, in this example, people do not simply choose the option that maximizes their expected monetary payoffs or values. They also evaluate utility of the payoff. Okay, the utility of the payoff for gamble B is greater than the utility of payoff for gamble A. Okay, so the point is to make here is that it is not that maximum expected value will give you will always give you the maximum utility. It can be otherwise, since here we have least expected value, but in this case the patient is able to survive with probability 1%. Okay, so 1% chance is that if he chooses gamble B, he will be alive, but in the first gamble he will eventually die. I hope I make myself clear in this video. If you like these videos, please share with your friends. That is the only motivation for me to keep going on. Thank you.